So this is another example. And now this is example 3, part 1, part A. Now my equation is given x equal 5 cos 3t, right? So this equation, they say that this governs a motion, this predict the motion of a particle, and the displacement of that particle is given by this equation. Now first we can have to show its simple harmonic motion. If it is not simple harmonic motion, we cannot use these equations. So first we must show that this is simple harmonic motion. So how do you show that? We have to start from this equation here, then we derive this with respect to time twice, and we have to show that it is similar to the characteristic equation. Right, so what is the characteristic equation? We should get x double dot equals minus omega squared x. Right, so let me just change the variable here to see, otherwise, so we can just change the variable, it doesn't matter, we can have to get a similar expression like this. Right, so if we derive this with respect to time, we get 5 cosine of 3t. When this is derived, you get 5 times minus sine 3t. Then you have to multiply this by 3. It's a chain rule. Right, so this is minus 15 sine omega sine 3t. So 3t. So let me just write this is minus 3 times 5. Now if I differentiate this again, d squared over d squared z over dt squared, I get, if I differentiate this again, I get 5 cos 3t times 3, you have minus 3 over here. If I rearrange this, minus right, so so you have minus sign here, then 3 squared 5 times cos 3t. So what is d squared z over dt squared? This is z double dot, we call it z double dot. Okay, so what is this part? This part is c. So we have showed, so let me rewrite it, z double dot equal to minus 3 squared, this part is replaced by z. Now this is the characteristic equation of the motion of the particle governed by this equation here. This is a characteristic. You can see that these two are similar. So only difference is this variable has been changed. So variables are different, so it doesn't matter. It should look like this equation. Now what is this constant? Constant is 3 squared. This means, this implies omega squared is equal to 3 squared. So omega is 3. So I'm just gonna take the positive quantity only. Right. So we have to show that it is simple harmonic motion. Then we can have to find the amplitude and time. Periodic time. So how do you find the periodic time? To find the periodic time, you know the omega, therefore t is equal to 2 pi over omega. Omega is 3, therefore 2 pi by 3 seconds. 2 pi by 3 seconds. This is the periodic time. So what about the amplitude? To find the now, since this this equation belongs to a particle in simple harmonic motion, so we can start with this equation to find the amplitude. Z divided by 5 equal cos of 3t. So you know that cosine function also oscillates between 1 and minus 1. C divided by 5 oscillates between 1 and minus 1. Therefore, this implies C oscillates between 5 and minus 5. Therefore, the amplitude of this motion is 5 units.